Moving on to how you solve these one variable inequalities, here's the first section of your toolkit. Our goal is to isolate the variable, meaning to get that variable by itself. Basically, you solve these the same way you solve equations. The only difference is if you multiply or divide by a negative number, we must change the direction of the inequality symbol. And then over here on this side, you can fill in whatever examples or notes you think are helpful. Before we actually solve some, let's just talk for a moment about why we change the direction of the inequality when you multiply or divide by a negative. The short answer is because we have to make the statement true. We're going to look here at 4 cases. In all 4 cases, we're going to start off with the same true statement. -6 is less than 10. That is true. Let's see the effect of negative numbers if we add or subtract. So let's pick a negative number. How about -3? If I take this and add -3 to both sides of the equation, what I would have is -6 plus -3, that's -9. Over here, 10 plus -3 would be 7. Which direction should the inequality symbol go to make this statement stay true? Well, -9 is less than 7, so it would point this direction. Notice, started with a less than, ended with a less than. Now, there was nothing magic about -3. We just chose any negative number to add on. So over here, let's do the same thing. We're going to subtract a negative this time. What would be a good negative number to subtract? Doesn't matter. How about a -8? All right, so we're going to subtract -8 on the left and subtract -8 on the right. Just like with an equation. In an inequality, what you do to one side, you can do to the other. That keeps things balanced. Minus a negative is the same thing as plus a positive. So -6 plus 8 is +2. 10 plus 8 is 18. To keep this statement true, I want to say 2 is less than 18. So notice, we started with a less than, we ended with a less than. Something slightly different is going to happen now when we do multiplications and divisions. Let's take a look. -6 less than 10. This is true. If we multiply by a negative number, like what if we multiply both sides by -2? -2 times -6 is +12. 10 times -2 is -20. To make this statement true, I now need to say, okay, 12 is actually bigger than -20. And notice, to keep the statement true, the direction of the inequality had to change. It has to do with the fact that negative means you're taking an opposite. So when you multiply or divide by a negative, you're making things opposite of what they used to be. That changes the direction of that inequality. And tell you what, let's do just one more here. Let's take -6, and this time we're going to divide by -2 on both sides. -6 divided by -2 is +3. 10 divided by -2 is -5. And to make this statement true, I would have to say 3 is the bigger one. Notice the direction of the inequality changed. So that's why we have this statement here. If you multiply or divide by a negative, then you got to change the direction of the inequality. The rest of this lesson, we're just going to work through lots of examples. So come back to this as often as you like. I encourage you to do pauses as we look at these and try them yourself, and then unpause when you're ready to check them. We're going to solve the inequalities and graph the solutions. All right, starting off with, my goal is to get the x by itself. So to do that, this +3 on the back needs to go away. -3 minus 3 is -6. Less than or equal to, and over here, those go to 0, just the x. The x is by itself. Now, this is a perfectly good solution. There's nothing wrong with this. However, that's not the way I'm going to leave it. And the reason is, to graph the inequality, it's typically easier if I have the variable on the left-hand side. So -6 less than or equal to x is the exact same thing as saying x. So notice here, the inequality is pointing at the -6. I'm going to have it point at the -6 over here. X greater than or equal to -6 is the exact same thing as this right here. I need you to understand that. You can switch the left and the right side as long as the inequality was opening to the X, it's got to stay opening to the X. Pointing at the -6, it's got to stay pointing at the -6. You may think to yourself, well, hey, Shrock, why do we do that? That just seems like an unnecessary extra step. It has to do with the graphing portion. It's just easier to graph if your variable's on the left-hand side. Because here's my boundary point, a boundary point at -6. It's got the equal line underneath, so we fill it in. X greater than means going to the right. And as long as the variable is on the left-hand side, I just want my arrow here to be pointing the same direction as the arrow here. So that's why I personally prefer to always keep my variable on the left. Okay, let's go again. At this point, I would like you to try a quick pause. Give this a shot on your own and then unpause when you're ready to check. All right, I'm trying to get P by itself. So first, an addition of 1. I'm going to pull up my calculator here because we're going to next divide by -7. So how much is 112 divided by -7? It's -16. So on the left-hand side, just a P. On the right-hand side, a -16. But we just divided by a negative number. The red number I divided by was negative. So the inequality's got to change direction. I'm going to make that, it looks kind of like an S. Needs to point the other way. So it was a less than. I divided by a negative. It's got to now switch to becoming a greater than. Go to -16. Open circle. And P greater than -16 means I'm going to the right. Cannot stress enough the importance of keeping track of your division or multiplication by a negative number. That's what changes the direction of your inequality sign. Next up, once again, I encourage you to do a pause, unpause when you're ready to check things. So starting, lots of 4s in this one. If I'm trying to get X by itself, these are kind of joined together on the top of the fraction. I want to save this part for last and get rid of the division by 4 first. So multiply by 4, multiply by 4. Those will reduce to 1 and therefore don't impact the results anymore. -4 times 4. Let's now subtract and subtract. No need to change the inequality. We didn't multiply or divide by a negative, and those go to -20. So on our graph then, at -20, open circle because there's no equal bar underneath, and greater than means I'm going to be going to the right. If my variable's over here, I want to go the same direction as that inequality symbol is pointing. Next up, I think just 2 more. Now on this one, you got some choices. I'm going to tell you, probably the easiest way, a way to just be consistent and do the same thing each time, is to distribute that front number through the parentheses. So do -3 times r and -3 times -2. Okay, we want to get r by itself. A subtraction of 6, a subtraction of 6. So -3 greater than or equal to -3r. Divide by that -3. Divide by that -3. So over here is a 1. Over here is an r. Again, I just divided by a negative number. That means this greater than equal has to become a less than equal. When you divide by a negative or multiply by a negative, the inequality sign switches direction. So this is very cool. 1 is less than or equal to r. This is a good answer. I want to remind you that if I'm going to try and now graph this, It's easier to graph it if the variable's on the other side. I can do that. I can move the variable to the other side as long as I keep in mind, all right, the inequality was pointing at the 1. It's got to stay pointing at the 1. So the solution I'm going to use for graphing purposes is the one highlighted in blue. R greater than or equal to 1. So at 1, a circle, I'm going to do this in red. The circle is closed in because of the equal bar underneath the inequality, and we're going to the right. Okay, last one. I promise you, they're not going to get more complicated than this. This is as complicated as things get. Ooh, let's take it a step at a time. Step 1. Let's distribute through the parentheses. So negative 2 times 6, that's negative 12. Negative 2 times 3n, that's minus 6n. There's a minus 7n on the back, and then a greater than negative 90. Before you try and get the n by itself, I want the n's to be in one place. Notice how my n's are on the same side of the inequality symbol. They're both over here. We're just going to put them together as they look. So this dashed or dotted underline portion, negative 6n's minus 7 more n's is just minus 13 n's altogether. So we've done two things. We distributed, we combined the like terms. Now we're ready to do our solving. I want to get n's by itself. That means that this 12 needs to go away. That's then going to give me a negative 13n greater than, and negative 90 plus 12 is going to be negative 78. I'm just doing a quick double check on my calculator because even I make errors if I try and do too much in my head. All right then. My goal is to get n by itself. We're going to divide by this negative 13. Divide by the negative 13. That leaves us with n. Negative 78 divided by negative 13 is 6. And the number I divided by was negative. Change the direction of that inequality. So my solutions at 6, open circle, because there's no little equal bar. And I want the less thans. Those are going to the left. So the good news, if you feel pretty good about solving equations with equal signs, then this is not that bad. If you're feeling a little bit nervous or a little bit apprehensive, practice is what makes you better. So work through this. As you have questions, talk with classmates or teachers, and we'll do what we can to help everybody out.